The fury of nature, a glimpse into extreme weather. From the scorching heat of prolonged droughts to the devastating floods brought by torrential rains, our planet is no stranger to the fury of extreme weather. These events leave a trail of destruction in their wake. But what drives these dramatic shifts in our weather patterns? The answer lies in the Pacific Ocean and the dance of El Niño and La Niña. These forces hold significant sway over global weather patterns, influencing everything from rainfall and temperature to hurricane seasons and beyond. Understanding these phenomena is crucial for all of us. By delving into El Niño and La Niña, we can comprehend the delicate balance of our climate system and their profound impact on our lives. Join me as we unravel the mysteries of these climate phenomena and explore their far-reaching consequences. The Pacific Ocean, the largest of Earth's oceans, is more than just a vast body of water. It acts as a colossal heat engine, driving weather patterns across the globe. Its surface, warmed by the tropical sun, interacts with the atmosphere above, creating a complex system of air pressure, winds, and ocean currents. This interplay between ocean and atmosphere is in a constant state of flux, a delicate dance of give and take that determines the distribution of heat and moisture around the world. At the heart of this dance lies a phenomenon known as the El Niño-Southern Oscillation, or ENSO, a recurring pattern of ocean-atmosphere interaction that manifests in two distinct phases, El Niño and La Niña. Imagine the Pacific as a giant bathtub. Under normal conditions, warm water piles up in the western Pacific, while cooler water rises to the surface in the east. This temperature difference drives winds that blow from east to west, pushing warm water towards Indonesia and Australia. However, every few years, this delicate balance is disrupted, setting the stage for El Niño or La Niña to emerge. El Niño, Spanish for the little boy, is characterized by an unusual warming of surface waters in the central and eastern tropical Pacific Ocean. This warming disrupts the normal pattern of ocean currents and atmospheric circulation, triggering global effects. During an El Niño event, the trade winds weaken, allowing warm water to move eastward. This shift alters atmospheric pressure, disrupting the water circulation. The consequences are far-reaching. The eastern Pacific may experience increased rainfall, while the western Pacific may face droughts. El Niño influences weather patterns across the Americas, Asia, Africa, and Australia. Section 4. La Niña, a chilling presence. La Niña, Spanish for the little girl, is the cool counterpart to El Niño. It is characterized by unusually cold surface temperatures in the central and eastern tropical Pacific Ocean, amplifying the normal east to west temperature gradient. During a La Niña event, the trade winds intensify, pushing warm water towards the western Pacific and allowing cold water to well up in the east. This reinforces the water circulation, leading to increased rainfall and flooding in the western Pacific and drier conditions in the east. Just like El Niño, La Niña's influence extends far beyond the Pacific, impacting weather patterns across the globe. The 2010 to 2011 La Niña event, one of the strongest in recent history, brought devastating floods to Australia, while parts of South America and the southern United States experienced severe drought. The event also contributed to an active hurricane season in the Atlantic Ocean. Section 5. A World in Flux, Global Impacts of El Niño and La Niña. The impacts of El Niño and La Niña are not limited to changes in weather patterns. These climate phenomena have cascading effects on agriculture, ecosystems, and the global economy. For example, El Niño-induced droughts can devastate crops, leading to food shortages and price spikes. Conversely, La Niña-related flooding can inundate farmlands, destroying harvests and disrupting agricultural production. These disruptions in food supply can have severe consequences, particularly for vulnerable populations in developing countries. Ecosystems are also profoundly affected by El Niño and La Niña. Coral reefs, highly sensitive to changes in water temperature, can suffer from bleaching events during El Niño, leading to widespread coral death. Shifts in ocean currents can disrupt marine food webs, impacting fish populations and the livelihoods of those who depend on them. The economic impacts of El Niño and La Niña are equally significant. Droughts and floods can damage infrastructure, disrupt transportation, and lead to losses in tourism revenue. The increased frequency and intensity of extreme weather events associated with these climate phenomena constrain resources, and hamper economic growth. Section 6. Predicting the unpredictable. The science of forecasting. Predicting El Niño and La Niña events is a complex endeavor, but one that has seen significant advancements in recent decades. Scientists rely on a combination of observations, statistical models, and sophisticated computer simulations to monitor the Pacific Ocean and atmosphere for signs of these climate phenomena. Ocean buoys deployed across the Pacific provide real-time data on sea surface temperatures, ocean currents, and wind patterns. Satellites orbiting Earth measure sea level height, which can indicate the movement of warm water across the Pacific. These observations are fed into computer models that simulate the complex interactions between the ocean and atmosphere, allowing scientists to forecast the development and potential strength of El Niño and La Niña events. Accurate predictions of El Niño and La Niña are crucial for mitigating their impacts. Early warnings allow governments and communities to prepare for potential droughts, floods, and other extreme weather events. Farmers can adjust planting schedules, water resource managers can optimize reservoir levels, and disaster relief agencies can pre-position supplies. Section 7. The importance of understanding, a call for global action. El Niño and La Niña are powerful reminders of the interconnectedness of our planet's systems. These climate phenomena, originating in the vast expanse of the Pacific Ocean, have ripple effects that are felt across the globe, impacting weather patterns, ecosystems, and human societies. Understanding these phenomena is not just an academic pursuit. It is crucial for our collective resilience and adaptation in the face of a changing climate. By improving our ability to predict and prepare for El Niño and La Niña events, we can mitigate their impacts and build more resilient communities. As we move forward, it is imperative that we continue to invest in research, monitoring, and early warning systems. International collaboration is essential for sharing data, expertise, and resources to improve our understanding and prediction of these climate phenomena. By working together, we can harness the power of knowledge to adapt to the challenges and opportunities presented by El Niño and La Niña, ensuring a more sustainable future for all.